Before a single punch is thrown, Mike Tyson has already won. This is a biological hijack, forcing the human brain into an ancient predator-prey loop. We dive into the neurology of fear to see how Tyson's stare shuts down the prefrontal cortex. Leading up to his 2026 exhibition match, the defining characteristic of Tyson's approach is absolute ocular silence. While opponents rely on motion and noise, Tyson exhibits a predatory stillness. The impact of this stillness begins the millisecond an opponent locks eyes with him across the ring. This diagram of the optic nerve pathway illustrates the sheer speed of visual data routing. The sight of Tyson travels from the opponent's retina directly into the superior colliculus, a region of the midbrain dedicated to detecting immediate spatial threats. This specific neurological route skips the reasoning centers of the brain entirely. It prioritizes rapid survival responses over conscious strategic thought. The body is preparing to live, not to calculate. The immediate physiological result is a precognitive surge of cortisol and adrenaline. The opponent's nervous system floods with stress hormones instantly, priming muscles for extreme action. Because this chemical cascade is routed through the midbrain, it triggers before the opponent can consciously process the visual data. Their body is already bracing for a fatal impact, while their conscious mind is still trying to formulate a jab sequence. Intimidation is a measurable physiological preemptive strike. By overloading the threat detection pathways, Tyson neutralizes his opponent's carefully trained strategy before physical combat even begins. To understand how a biological mechanism deletes technical skill, we have to look at the thalamus. In a normal, low-stress environment, the thalamus operates as the brain's air traffic controller, methodically routing sensory signals up to the thinking brain to be analyzed and acted upon. This cross-section of the brain shows the mechanical failure that occurs under extreme stress. When the thalamus detects a severe threat, it actively shuts down access to the prefrontal cortex, the area responsible for executive planning, logic, and self-control. Instead of traveling up for logical processing, the signal is rerouted, dropping straight down into the amygdala, the brain's primal fear center. Sports psychologists define this specific routing error as the amygdala hijack. The body is flooded with electrochemicals, and the executive function of the brain is silenced. For an elite athlete, executive breakdown is devastating. Without access to the prefrontal cortex, the complex, highly calibrated athletic patterns they've spent thousands of hours perfecting become physically inaccessible. The athlete instantly regresses to basic stored survival reflexes: fight, flight, or freeze. Decades of technical mastery vanish in a fraction of a second. This clean, rhythmic sine wave represents the optimal neural oscillations of peak performance. In elite sports, this is often called the blue head state: loose, expressive, accurate, and completely on task. During a hijack, the brain enters the red head state. The clean rhythm shatters into chaotic, high-frequency neural noise. The fighter becomes tight, inhibited, and desperate. This high-frequency noise directly disrupts motor cortex readiness. The muscles receive erratic, conflicting signals, which drastically delays physical reaction times. An amygdala hijack effectively deletes a boxer's game plan from their accessible memory. They are left functionally defenseless, operating on raw panic against a strategic, highly lethal threat. This evolutionary mechanism leads directly to tonic immobility. In the wild, when prey is confronted by an overwhelming apex predator, the nervous system often triggers an involuntary total freeze. That exact ancestral prey response survives intact today. When a highly conditioned athlete freezes across the ring from a dominant opponent, you are watching a million-year-old survival program executing itself. A major biological misconception is that the freeze response is a passive shutdown or a form of surrender. The reality is the exact opposite. Looking at this silhouette, we can see the massive metabolic cost of tonic immobility. The body is entirely rigid, but the brain rapidly consumes huge amounts of glucose, hyper-processing the threat environment to determine if survival is even mathematically possible. This brings us to Tyson's specific physical behavior. He rarely bounces, he doesn't pace, and he displays an absolute lack of wasted movement. This absolute stillness forces the opponent's nervous system to categorize Tyson as an inevitable natural disaster. The brain stops seeing a sportsman to be outboxed and begins preparing for a catastrophic event. Contrast Tyson with opponents who display erratic, high-energy movement, smashing equipment, shouting, or constantly pacing. Erratic behavior registers to the brain as human and therefore flawed. Because the threat is recognizable, the opponent's brain keeps the prefrontal cortex online, allowing them to formulate a counter-strategy. Tonic immobility is uniquely devastating in combat sports. Boxing demands constant kinetic problem-solving. An athlete locked in a high-metabolism freeze is a stationary target entirely incapable of returning fire. Tyson's lack of movement is an active neurochemical attack. He weaponizes millions of years of human evolution, forcing his opponent's biology to betray their own training. In a shared high-stakes environment, two competitors engage in a neurobiological phenomenon known as brain-to-brain coupling. These two side-by-side brain waveforms illustrate how the neurorhythms of a highly confident, dominant fighter can physically force a weaker fighter's brain to mirror their stress state, dragging the opponent's biology into compliance. Physically, this coupling manifests as a severe drop in heart rate variability, or HRV. The submissive fighter's heart rate loses its adaptability, locking into a rigid, panic-driven rhythm. Biometric data gathered from modern 2026 exhibition matches proves this phenomenon occurs routinely at the elite level. When one fighter exerts biological dominance, the other's internal metrics plummet. This localized drop in HRV restricts blood flow and oxygen to critical areas, directly depressing motor cortex readiness. The weaker fighter literally becomes slower and less coordinated. A broken spirit in sports is a literal, measurable biometric failure of the nervous system. Once this coupling is achieved, a brutal biological feedback loop begins. The dominant fighter's brain subconsciously reads the opponent's involuntary micro-expressions, pupil dilation, minute postural shifts, changes in respiration. Processing these distinct markers of fear neurochemically reinforces the dominant fighter's own predatory state. The weaker the opponent gets, the more lethal the dominant fighter becomes. Compare this dynamic with a fighter who maintains high HRV. An athlete who stays loose and refuses to couple with the predator's rhythm presents an entirely different biological puzzle. Maintaining a neutral, unbothered biometric state completely blocks the predator's feedback loop. It denies the dominant fighter the chemical reward of fear. Physical contact is secondary. The outcome of the fight is largely decided on a biometric level, through neural synchronization, long before the first bell rings. The only defense against a biological hijack is a neuropsychological countermeasure, known as cognitive reframing. By consciously identifying the specific pressure they are facing, an athlete intentionally shifts from a threat mindset to a challenge mindset. This verbal acknowledgement protects the nervous system from triggering the thalamic bypass. The 6-second countdown clock intersecting the chemical line graph reveals a critical biological vulnerability. The initial electrochemical flood of an amygdala hijack naturally dissipates in precisely 3 to 6 seconds. An athlete's primary survival task is incredibly narrow. They only need to survive this 3 to 6 second window without internally escalating their own panic. If they can breathe and hold on, the chemistry clears. Modern elite fighters in 2026 do not leave this to chance. They prepare their brains specifically to weather this exact 6-second window. Training camps now utilize sensory deprivation and VR neuropriming. Athletes are repeatedly exposed to hyper-realistic, intimidating stimuli in a controlled environment. This repeated exposure physically desensitizes the amygdala to the specific site of an apex predator. The brain learns that the visual trigger does not equal immediate death. This protocol builds a deep neural tolerance. When the athlete finally steps into the ring, the thalamus detects the threat, but the prefrontal cortex stays fully online, allowing the fighter to execute their strategy. Understanding the sheer chemistry of intimidation is the only scientifically valid way to regain executive control. When you map the neurology of fear, you strip away its power. Dive deeper into the hidden secrets that shape our reality. Click the subscribe button, activate the bell, and see you in the next scientific investigation beyond the boundaries of reason, only on TEMBODocs.